Hi, I'm Paul Brodie. We're in the shop. Got a bunch of AERMACCHI stuff to do. We're calling this episode Race Mods. And Mitch behind the camera. We have 4 things to do today. We hope you find them interesting. Thanks for tuning in. And we'll get going. I think the first thing we're going to do is to take the muff off the liner. This is the muff. This is the liner. And so I put it up on heat blocks. I grab my big torch, not my really big torch, but a fair-sized torch, and I heat up the muff, and the liner should fall out. So we're going to use the torch for 2 different operations today. This is the first one, so I'll set it up over here. If you're wondering why I'm taking out the liner, it's because this is a big bore motor, and the new piston is 5 millimeters larger. So that means that the liner has to be larger too. So we have to hold the muff in the lathe and bore it out. First we'll take out this liner. Ooh. Always got to keep the torch moving. You never just hold it. Got to keep it moving. I got my hammer, so not yet. Ooh, little noises. Getting warm. I see a little bit of smoke coming off. It's a bit tight, I must say. So often what happens is you heat up the muff and the liner just falls out, but not this time. Maybe we do need more heat, just to get the last little bit out. It's out. It just popped out.
Oh, it's under the, okay.
Yeah, it's done. Okay. Oh, well. Okay, the second thing we're going to do is to heat up the end of the pinion shaft. On a set of flywheels, the one side, usually where the can is known as the pinion shaft, and the other side is known as the sprocket shaft. So this is off a 1973 motor, electric start, and this is an earlier model, and it has to match this. So everything from here to here is exactly the same, with the exception of the worm drive for the tack. So this has to come off, but in the end of the shaft is a taper, and usually that's done with a center drill, but I got to use a carbide tool because I'm going to hold this in the lathe. This is going to be held in the steady rest, and then we can make the taper perfectly concentric. I can't think of the name of the taper, what that's called. I know it's a 60 degree. I was talking to Mitch earlier about this and can't remember the name, so you can tell me. How about that? So what has to happen is I have to heat it up because this is all hardened. You can hear it. Can you hear that? That means that is very hard. So I can't make this. I can't cut the taper until I take out some of the temper. So what I'm going to do is I'm going to grab my torch again, going to heat this up, not go too far. And over here I've got a box of lime, and I put it into the lime, and that allows it to cool very slowly. Takes out the temper, because when you heat treat something, you usually quench it, so the temperature comes down fast. That's part of the heat treating process. So I need to heat it up and then allow it to cool slowly. There we go. Oh, turned blue there. See that? That got hot. Okay, it's getting a little bit red, so that's good. Okay, we got some redness there. There we go, it's in the line now. Okay, so we just leave that till next time now, because that's going to take a little while to cool down. And we're on to the third thing. I had some broken fins on the crankcase here. Mitch show you a picture. So I did a little TIG welding yesterday, and maybe it looks a little sloppy, but it's not easy welding on top of a fin and having it kind of just burn away. So what we're going to do now is, that's a lot of filing. I'm going to put it up in the mill, take a very small end mill, and go along here and here and then the last part will be the filing. So that was my best welding last night. That's not easy. I've got a 3/16 end mill, and I'm cutting the weld, and the weld is soft. It's not heat treated, so it doesn't cut really nicely, but it is what it is. All right, so I've taken most of the weld off, so what's left is a little filing. I can do that on my own, but that's basically the process. You weld it up. If you can machine it, it helps because it's faster than filing. And we're on to the next step. The last thing we're going to work on today is the shifter quadrant. That's this piece here. And it goes inside the case, and it's what shifts, helps to shift. So it sits in the middle. It's got a spring that goes on there, and then it goes like that and like that, so that when you shift, it goes back and forth. Now, this is out of a 4-speed, 71, 72, and this is the 5-speed. So this goes a little too far, so this is the stop. So we have to make a new one. I actually have a drawing today, and we'll press out this piece, and we'll make the new one, and we'll press it in, and then everything's cool. So I think the first thing we'll do, we'll go to the arbor press. I made up a tool that's gonna work with that, and we'll press it out, and we'll see how hard it comes out, because that'll be the press fit. If it comes out nice and, well, if there's a bit of pressure to push this out, then I'll make this pin the same size as this. Make sense? Good. Go to the arbor press. There we go. That's a good fit. Okay. .4655, that's fine. Okay, now we machine the shoulder. I got to put a groove in here now for the spring to hold it in place. Okay, so we go to the hacksaw now, we cut it off, we come back, we face it, and we press it in, arbor press style. Okay, let's go put it in. Oh, it's going in pretty tight. There we go. All right, I think we've had a successful day in the shop. I got done what I wanted to accomplish, and that's always a good sign. Thanks, Mitch, for filming. Thank you for watching. If you haven't subscribed, please do. We're heading for that 100,000 mark. Mitch and I like coffees. Please buy us a few coffees. And we'll see you next time. Take care.